Welcome to another episode and video on my driving robot discovery based on the fischertechnik TXT controller running embedded Linux and programmed in online mode in Python. It is supposed to drive in a straight line using Sonar and 2 touch sensors, and then drive 2 objects and following some kind of trajectory. That doesn't always work out. The algorithm recently has changed to hold or to stop in between to make a message, an image, picture, and in such a way that it nicely shows the trajectory. However, when I measure the distance like this, then the distance is about 50 something centimeters, which is then some 21 inch, and as yet the pictures taken by Sonar are not further than 30 centimeters, so I have to add some. Apart from that, for some reason it leaves it straight trajectory. So in order to show, let's run and see whatever happens. If something happens, yep, something does happen, and it goes from its line and it says that the counters for the motor are not equal, so in that perspective it should hold. But why it skips a lot of things like pausing for an image, making a sound, blinking a lamp, like this is a lamp that should burn, but it doesn't, as you can see, there's no sound. But the algorithm hasn't stopped yet because the propeller is still running. And it still goes on taking images. Now it is ready. So what causes what? Well, an OpenCV error causes the program to stop, and that is because the latest image taken is 0 bytes, so it has no content, and OpenCV can't deal with that, so it ends in error. And with that, let's take a look at the screen, whatever may have happened. Alright, so this is the error what I was talking about, because of this, all 0. First of all, that's also then the battery, 8,6 volts. And what the voltage reading concerns, after well, it drains, controller drains the battery, but it shouldn't be drained completely, because that is not good for the battery. Anyway, apart from that, let's take a look at some images. Actually, these, and then there are only 3, and in the coda let's take a look at this is action 131, which belongs to a distance of 10 to 12 centimeters, which is, and of course I do not know which object it was, but I suspect this one, and 10 to 15 centimeters is this. So that is not very far away. Then there are what is 0? Well, 0 is right at the end. So between, once again, between here and here, it didn't do a thing. Not well, not a thing with the cameras anyway. So let's take a further look. Yeah, braking sound didn't do it. Anything else? Gray, yeah, I should actually disable gray because it's of no use at all. I want red. And I did implement red with the other robot, walking robot, but not here yet. And I could do that, but let's first make sure that I get the trajectory correct, which starts here. So I need, well, starting at 50, between 30, that's 4 if conditions, 30 to 35, 35 to 40, 40 to 45, and 45 to 50. 4 if conditions, and each of those if conditions gets camera action. So then you should actually be able to see which course it takes. But there's a huge but or if or whatever. It also has a sonar distance between 25 and 30, and between, yes indeed, 25 and 20, and it doesn't do that. And I can tell it doesn't do that because camera action, oh wait, no, not wait, because this is the date, this is the time in 2 seconds, and this is the this and this are the camera moments. There is no 30, and neither is there, where is it? Oh, that's contact. So there's no 30, and neither is there 25. So is it useful to implement more if conditions if these conditions aren't even met? And if so, why aren't they met? I can also take a look at the distances. Starting distance 15 centimeters. Wait a second. I can test that, of course, and that won't be hard because using Robo Pro this is correct, and with this I can what is the entrance of the sonar? That will be I8 ultrasonic, 11 centimeters right now. Well, not true of course, but with that I can easily measure if it takes the distances correctly. So let's do that. So with the robot on 66 centimeters according to Robo Pro. So what is 66 centimeters? Alright, that's here. Then 25 to 30. So let's say what's in between? 27. No, closer. Almost. This is 30. This is 30 centimeters. Robo Pro says 31. Okay, no problem. So let's go to 20. This is about 20. And Robo Pro says 21. I'm okay with that. That means that the sonar is kind of accurate. I don't have a problem with that. But let's put it to 30, which is this kind of. Alright. Well, a measuring lint like this is kind of rough. So let's take a look. It's at 34, right? Yeah, 34. That means that is this distance. And you always have to take an angle. So let's take some. Then this is 30 something, and then this is 30 something, and okay, 32 according to Robo Pro. I'm fine with this. Now let's quit this and run the program. This is better because I need this one to check. Alright, so let's run and see if it takes the furthest condition on sonar at all, and then I should get action 30. I'm very curious. Let's go. Uh-oh. Stop. That was a display reset. once again. What will happen, if anything? Well, it has the 0 image in any way. It runs and it stops because it is 0. The question, where is it? Where has it been? In which condition has it been? Has it even been in a sonar condition? That is a very good question, because without it I can add any condition I like, but that won't work. And it hasn't been in any. It just doesn't do it. Battery 8,5. That's enough. Okay. That means that it's no use to compare any images. Let's put it back at 30 and try again. Again, a problem, and the big one. Go. And a 0 image. Now it does something. We have a 0 image. Only 0 images. And an 11 image. Interesting. 11 image. And this is also very interesting, that it completely pushes the object away and makes quite a turn. But the 11 image is contact. Most interesting. And the 4, I know that I don't have to look at that one, because the 4 is end of the algorithm. The last, almost the last line in the algorithm. So my idea of adding more sonar conditions for now has no use at all. Makes no sense. But the question is, why? Another piece of analysis where it comes to distances. This one, CA11, is 16, but it is already after contact 2. And here the algorithm starts, and it says CAS 31. Well, I don't need to check that because I started, I think, at 31, but Yeah, let's find this one. Alright. Oh, interesting. Camera action end. Let me change this text to actually that is sonar distance, camera action, camera action and. I think this is much more clear. Much. And I don't have to see that. And then it says which distance. Again CAS and CA0. Where is CA0 again? Ah, camera action 0 is right prior to the first contact statement, if statement. That is 15. So that is kind of interesting. Between ending the camera action, the first camera action, because this is still 0, and the first condition, it has already driven 15 centimeters. Is that wise to do? I have my doubts. Here is camera action 0. Before this, there's no camera action. Which means that in between this action and this printing, between these two lines, a distance of 15 centimeters is being covered. Ouch. That also means that I have to actually stop the motors. Yep. I have to do exactly the same as I do here, and then start them again. Like I have done with the sonar conditions. I have to stop them. I have to stop the motors from running. Stop the motors, camera action 0, start motors again. Because this means that camera action 0 is not at the start of the trajectory, it's 15 centimeters after. Or anyway, this is 15 centimeters after. And why do I stop motors? Well, I have to. Yeah. I already put it here, but I haven't implemented it yet. So the whole trajectory idea of taking images at the start of the camera, at the start of the action, that's not implemented. Ouch. And then again, well, this is only executed when there's a contact. I start at, that's all, of course that is important. if I start at 30 centimeters like I did right here, because that is what happened, and then before it comes to the contact it has already covered 15 centimeters, and 30 minus 15 is 15 centimeters, give or take, in this case. Should it have then made another call, because then we are here in this condition, and then what is the camera condition? 13. What is the camera condition? Not 13. Next camera condition, 131. And what do I have? 131. So it makes sense. It makes total sense. It just doesn't make sense when I start at 60, because when 60 centimeters minus 15 is still 45, and then it should have taken the 30 centimeters limit, but it hasn't done that. So that's not quite accurate yet. So how to proceed? Well, implement, go back, here, and implement this, and then see whatever happens. And with this analysis, quite extensive as well, I have come to the end of this episode, which went completely different as I anticipated, but that has happened before. And yeah, like I said, I have yet to implement the stop and restart of the motors to prevent it to drive 15 centimeters during taking of the camera action and the first covered distance. What else? Well, color implementing and finding out exactly the rest of the sonar, if that is being covered after I have eliminated those first 15 centimeters. And whatever comes next. Color separation. Sound, because I'm not happy with that at all. And whatever comes next. So, thank you for watching. If you like this video, please subscribe to my channel if you haven't done so yet. Also, give the video a thumbs up. Like it. Leave a comment, very much appreciated. You can also follow me on Twitter. If so, retweet and like. And leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please donate to keep videos coming to you. It takes time and effort to make them, so kindly appreciate it, some support. And you can also become a patron and have your name mentioned as a supporter, either on my website or on my website as well as with the videos, depending on the pledge you make, and it's voluntary but very much appreciated. And this is going to be continued. So thank you for watching, and bye bye.